So the focus of module 3 is layer 3, and the star of the show, or the stars of the show, are something we call routes. And they're done through a piece of equipment that's specifically designed for that purpose called routers. And on the edge of a network, when they're connected so that people can browse out to the internet, the router port is actually called a gateway. So the physical port on the side of the router that people use to access the internet and to get out into the public for any purpose, email, web, social media, apps, streaming stuff, any of that. That's called the gateway, the physical port on the side of the router. So another name for router is gateway. I was telling you on Wednesday that the star of the show in module 2 on the local network, layer 2, we had something called a broadcast domain, or in other words, the local network. And that there was this cool feature called a VLAN that allowed you to extend the broadcast domain into something called a bridge domain. Does everyone remember this? Bridge domain? A bridge domain? Bridged domain? Yes, no, maybe? You use the term bridged domain when you have a local network segment connected to adjacent local segments, and you can extend the broadcast domain between local connected network segments. But they're all basically part of the same, like the same physical network, And you can greatly extend a local network into sort of like a metropolitan area network, like the campus of UVI, on layer 2 by creating these bridges between broadcast domains for bridge domains. You create a bridged domain between two broadcast domains so that you can kind of extend local area networks, segmented networks, right? LANs. Now, layer 3 takes everything to a whole different level. So IP networking allows for routing. And what we were attempting to demonstrate on Wednesday was this idea of how a router works and it fits in between two network segments. So I'm going to go ahead and everybody can still see my screen, yes?
Yes.
Okay. So let's pretend that we have two switches. I'm just going to drop two switches here. And this is switch 0. And I'm going to create switch 1. All right. And ordinarily, let's see, let's get end devices. I want a PC here. And I'll put a laptop over here. Everybody with me so far?
Yes, this is the one that you want us
Yes,
to
I'm
follow
here.
along with you, right?
Yes, this is the one that we wanted you to, well, just watch at this point though, because we're gonna set the stage and I need to talk about how routes are configured. And I'm gonna walk through some things first before we do the solution steps. So this is like a baby version of what you're gonna do for the solution. So I want to pretend that these are two different networks. I don't have to pretend. I can actually create in the configuration. I'll create on the fast Ethernet, right? I'm going to give it an IP address and I'm going to call this 192.168.0.11. Okay, everybody with me?
Yes.
Okay. And then in the global settings or the interface settings, let's see. Where was it we put the gateway address? Fast Ethernet. Interface, global. Settings, there it is, settings. So we're not going to worry about DNS right now, but we're going to put a default gateway that is consistent with the conventions for gateway assignment. We have a 192.168. On the interface, we have a 192.168.0.11. And if we use this subnet mask, we get a network ID of 192, a network identity of 192.168.0.0/24, because there's 8 ones here, 8 ones there, and 8 ones here. Everybody with me so far?
Yes.
Yes.
All right, so my default gateway, if I want to get outside this network, I'm going to define a default gateway by adding 1 to the network identity, which is 192.168.0.1. So instead of saying 0.0/24, I'm just going to say 0.1. Now I don't have a router configured yet. Okay. But that's the first PC, PC 0. And now I'm finished configuring PC 0. Now, what I'd like to do is let's connect these two switches. Okay, let's just get them connected. I'm going to use the automatically choose connection type, and I'm going to drag. I'm sorry, I'm going to drag from here to here. So I've connected switch 0 to switch 1. Can everybody see what I've done here?
Yes.
Okay. And I've connected them using a copper crossover cable, right? So when we're connecting network equipment to network equipment, oftentimes we use what's known as a crossover cable. That's different than the cable we use to connect end user devices or hosts on the network to the switch. And you'll notice we just went from a orange status to a green status. Everybody saw that? So the two switches are connected together. Now I'm going to connect the PC to this switch. And it's going to take a second. But eventually, what will happen is that this PC is going to start to negotiate with switch 0. And eventually, this is going to turn into a green triangle. Because there's a MAC address table that's populating here. And it takes the MAC address from the PC 0 on layer 2. And then it builds this. It uses ARP, address resolution protocol, and it says, okay, oh, I have something going on here, and then eventually it syncs up, and it says, oh, I got a connection. So now this PC is connected and it's ready to go, and there's a connection between these two switches. Okay. Now, if you remember our first assignment or of the last module, we had you build something in here. And we had you configure the two PCs to be on the same network, and you could ping each other. And then we had you change the IP address so that they were on different networks. Does everybody remember this?
I remember doing it somewhat, yeah.
Yeah. So originally we had PC 0 and PC 1, and we put them on the same network, 192.168.1.11 and 192.168.1.12. And then you pinged, you used the ping command to connect and to get packets back and forth between the two PCs. And then I told you, okay, let's put it on a different network, right? Because if they don't share the same network ID, they can't talk to each other. Now I'm going to do that here. I'm going to actually connect this PC or laptop, and I'm going to put them on a different network. They're not going to share the same network ID. So in this case, I'm going to use 192.168.1.11 instead of .0.11. And as soon as I hit the tab, it automatically fills in the subnet mask. My gateway address is going to be a little different. So I want to properly configure the gateway address, because if I'm going to try to ping the 0 network over here from the 1 network here, I have to have a gateway in place, or I can't leave the local area network. So this is a local area network. 0.11, right, is the first host that we set up. 192.168.0.0. And on the other side is the 192.168.1.0 network ID. Everybody with me? Kind of, sort of, maybe.
Yes.
So my network identity on this side is 192.168.1.0/24. That's my network identity. But if I want a gateway, I'm going to add one to the 1.0. So I'm going to make the gateway 1.1. Again, I'm forgetting about DNS server for the time being. So I have 1.1 and I have a proper gateway, because I have to have a proper gateway if I want anything to leave this local network. And if I'm going to try to ping this one over here on a different network, I have to have a gateway. So I've gone ahead and done that. And now this laptop is sitting there waiting to get connected. And I'm going to connect this laptop to its switch. And so the two switches are connected. They should be able to talk to each other. And the 0 network over here, 0.0 network, right? This network is different from the 1.0 network. But because they each have gateways, I should be able to send a packet from here to here. And we know that on layer 2, that's not possible, because on layer 2, the only devices that can talk to each other are the ones that share the same network ID. And we know that this is in a different network and this is in a different network. So when I try to ping, if I go to the desktop and I open up a command prompt and I want to ping this laptop over here, which is 1.11, I'm going to do a ping dot. Well, let's just try to ping myself first, okay? I want to make sure my IP protocol stack is working correctly. So I'm gonna ping the gateway. No, I don't actually have a gateway defined on the router. I have a gateway configured on the client. I'm gonna ping myself, and I can ping myself. Does everybody understand what I just did there? This is PC0. It's configured with an IP address of 192.168.0.11. And I just want to make sure that my network is functioning properly. Now I'm going to try to ping this laptop, which I set up on a different network. And this is all layer 2, right? So I go ahead and do this. And I try to ping 1.11 now. So I'm sitting on here and I want to ping this laptop, and it's sitting on a different network. I have properly configured gateways. Am I going to be able to ping it successfully? What do you think? Anyone? Hello, hello. So because we don't have a router in the mix, we're still operating on layer 2. The only devices that can interact with each other have to share the same network ID. Each of these machines, the laptop and the PC, share a different network. They don't share the same network ID. They each have different networks, even though they have a properly configured gateway, so they can go out of their own local network. Will I be able to ping the other machine on a different network if all I'm operating on is layer 2? Yes or no? Okay. I want all of you, everybody here is familiar with Medea, yes?
Yes.
Okay. Tyler Perry, the actor, plays a character called Medea. She's a crazy aunt. Yeah. Her favorite phrase for me is hell no. I want you to repeat with me, all of us, out loud, all at once. We're going to do some deep processing here. I want you to say, when I ask you, can I ping something on a different network ID if all I have is layer 2? And your answer is going to be, oh, hell no. Everybody ready for the question? Is everybody ready for?
Yeah.
Okay.
Yes, I'm ready for the question.
So can I ping another device if it's sitting on another network identity, if it's using another network ID? What is your answer?
Hell no.
Oh, hell no.
Hell no.
Hell no.
Oh, hell no. Yeah. All right. Okay. Now, can I ping? Let's see what happens. Nope. It's going to time out. It's not going to work. Now, we knew from our first assignment in module 2 that if I changed and put them on the same network ID, that I could ping them. They could ping. That's what you proved in your first assignment. You had 2 devices. They were separated by a couple of network pieces, right? These 2 switches, and they could ping each other. But they were on the same network ID. And then I changed the configuration so that they were on different network IDs, and I got this result. I got the same result. And that's what you submitted. You submitted one result where it was like, okay, they can talk to each other, and then, oh no, they can't. Everybody remembers this, yeah?
Yes.
Yes.
Okay. I actually posted credit for you on that assignment. You should see that you scored credit, and I posted it on Blackboard for that. Okay, now, here's the thing. I want you to realize that when you talk about switches and hubs, all you have is layer 2 to work with. And layer 2's constraint is you have a broadcast domain. It is a physical network. There are distance limitations. You can use some magic to extend that by bridging 2 broadcast domains, 2 different network segments, but you have to use VLANs. But that's still layer 2, right? So you're still kind of stuck. You can kind of extend local networks, a broadcast domain or a local area network, right? By bridging broadcast domains, so that you create a bridged domain using virtual VLANs. But you're not going to do an internet. So what am I saying? Back in the day, they had campus networks, but they didn't have internet. They had computers on a network, and the computers on the campus could talk to each other, and it got pretty big. They had computers all over the campus. So you could be at a very large university in the States, and computer in a human resources office could talk to a student registrar's office, could talk to a athletic director's office, could talk to a faculty member's office, could talk to the student laboratory computers, and so on. But they were all layer 2, and no universities could talk between themselves. We did not have a global internet. That's the part I want you to understand instinctively. If you're layer 2, you're limited. L for layer 2 means limited, okay? Layer 3 means whole nother level, right? In fact, a layer 3 switch includes routing. And what I want to show you here is that you insert a router here. You connect this switch to the router on this side, and this switch to the router on that side. And you have 2 interfaces. You have the left interface and the right interface. We'll call them interface 0 and interface 1. And interface 0, well, all right, let's just do it. So I want to create an internet. I'm tired of having a large network, but only in a local area. It's nice and it's fun and it saves me some footsteps, but I have friends at other campuses and I want to stream Netflix and I want to do email And I can't do any of that yet, right? So what I'm going to do now is I'm going to remove this link. I'm going to actually get rid of this link. And hang on. Oh, I see what happened. I got to go back to this. I'll do it here. That's going to take a second. I need to get this thing. There we go. I need to get rid of this thing. And I'm going to, yeah. I think what I'm going to do is start all over again. Okay, everybody with me?
Yes, we're with you.
Okay, so let's start over again. I'm going to put a router out here. And I'm going to put a router in the middle because I want to be able to create routes between networks so I can build a global massive internet. That's what I want. I want to take things to a whole nother level. So when we're talking about the 1970s, the 1980s, we had that previous diagram you're talking about. And then everybody was like, wait a minute, we got to be able to talk between universities. If we're going to be networking, we might as well go global. So this idea of routing came about, and the idea of a layer 3 and the IP protocol. And I got to tell you, Dr. Boumediene, the next time you see Dr. Boumediene, I want you to thank him because some French pioneers came up with the idea of TCP, the idea of creating a session and being able to do things with IP networking. And that was a tipping point, right? So what happens is that some French pioneers were collaborating with American pioneers and German pioneers and British pioneers and everybody all over the world. But it was the French who came up with this idea that, you know what, we got to be able to connect between systems for client server where they share a session and the connection remains intact. And that led to really big things. So in order for IP networking to work, though, you have to use routes. And in order to use routes, you have to have something intentionally designed or purpose built to manage routes. So what I'm going to do now is put those switches in place. And I got one switch here, and I have another switch here. And I'm going to go ahead and change to the clients. So I have a PC here, and I have a laptop there. And I'm going to go back to this, right? And I'm going to connect between like here and, no, I want to connect between here and here. No, here and here. And I'm going to connect between here and here. So now I have a router in between with my switch. And I'm going to connect the first PC to the first switch and the laptop to the second switch. And now I'm going to go ahead and configure. So I said that this gateway was 192.168.0.1, and the Ethernet network address was 192.168.0.11. Everybody remembers that, right?
Yes.
Okay. Over here, I do a one network. So I have 192.168.1.1 because I'm not doing 0.1, I'm doing 1.1. I have a different network identity. On my fast Ethernet port, I'm gonna give the Ethernet port an IP address of 192.168.1.11. So this has 0.11 and the laptop has 1.11. All right. And what you see here is an arrangement where the link between the switch and the routers isn't active yet. One of the things that I want to share with you, and this is going to be a kind of a tricky part. So I'm going to take a screenshot here, and then I'm going to open up a new paint window. One of the things that I would really like to get across is this idea of interfaces, right? So the router itself has multiple interfaces. And just like the first router in a mix is called router 0, what do you think the first interface is right here that we connected initially is going to be called? What's its number? It's going to be interface what?
0.
0.
0, exactly. It's going to be interface 0. And then this one's going to be what? Next in the sequence? Interface
1.
1, exactly. I want you to get used to the idea that the very first interface on a device is always 0. And the very first device, or the first system, the first piece of network equipment is always a 0, right? And then when you keep adding, then it's 1, then it's 2, but 0 is like the first. So you have router 0 and you have interface 0, okay? And the thing that I want you to remember is this is network 0.0 and this is network 1.0. For simplicity's sake, we're going to say this is network 0 and this is network 1. Now, this router doesn't have a route yet. Let me repeat that. I haven't configured a router yet. I haven't set up a route. But what I want this router to be able to do is to receive a packet from the 0 network. And if it's not in the 0 network, if it's supposed to go to the network 1, I want the router to work like a post office. So the router is going to receive a packet that I'm sending from the PC to the laptop, right? So I'm sending it to the laptop. And as I'm sending it, it's going to go through the router. And when it goes through the router, it's going to hit interface 0 on router 0. And when I configure this interface, I'm going to tell this interface, hey, if you get a packet for network 1, it's over here. It's over on this side. And the router is going to refer to the interface on this side. It's going to say, wait a minute, if you need network 1, pass it on to interface 1. So if I get a packet for network 1, I want you to route it out interface 1 to network 1. So on interface 1, right, well, on interface 0, I have a route that I create that says, hey, if you want to get to network 1, go through interface 1. And that's as simple as it gets, but I'm going to repeat that. The packet comes along and the router says, hey, if you want to get to network 1, use interface 1. Okay. Now, what do you suppose happens when I'm trying to ping and the first packet goes this way? A ping sends a packet out and then a packet's supposed to come back. When the packet returns, it's going to hit interface 1 on router 0. So what am I saying? I'm saying that laptop 0 receives the packet from PC over here, PC over here. And it says, okay, I got it. It's going to send that reply back. And when it sends the reply back, that return packet's going to hit the first interface on router 0. And it's going to say, hey, back at you, network 0. Now the router has to have a rule for what? If you're going to return the packet back to network 0, what does network If something in network 1 wants to send a reply back to network 0, what do you suppose interface 1 has to have? It has to have a route for network 0. Let me repeat that. When you send a ping from the PC to the laptop, it has to go this way, and it's going from network 0 over here to network 1. So it's going to hit this port, interface 0, and on this interface 0, there has to be a route that we add to interface 0 that says, hey, if you want to go to network 1, push that packet out of interface. Interface 0 is going to say, hey, if you want to go to network 1, go through interface 1. The laptop answers and sends a reply back to the PC. And when it hits interface 1, if you don't have a route on interface 1 for network 0, the packet's not going to return. You have to have a route going out, and you have to have a route going back. The route going out is on this side on interface 0 if you want to go to network 1. The route going back is on this side. If you want to go to network 0, you have to have a route for network 0 on interface 1, okay? On this side, the right interface. Does that make sense?
Yes, that makes sense.
Otherwise, what happens is your packet goes out and it reaches the laptop, but it doesn't come back. You have to have two routes. A route that knows about network 1, and it's on the interface 0, network 0 side. And you have to have a route on the network 0 side for network 1, right? So remember that routes require two directions. And they always work in pairs, like left and right mittens or gloves. You have to have a to and you have to have a from. And you have to think about, okay, the direction. That's why these diagrams are so important. There's a dimension to this, and diagrams help you set up in your mind's eye, okay, where am I putting stuff and where do these routes go? Well, if I'm going to send something from here to there, I got to have a route from here to there. If I'm sending a packet back from the laptop back to the PC, I have to have a route from here back to there. That means I have to have a rule that says, oh, network 0 is over here. If I'm sending something from here to network 1, I got to have a rule that says, oh, network 1 is over here. You got to put each of those rules or each of those routes on each separate interface. And the thing that gets tricky or confusing is understanding that the route that you add has to be on the interface that's receiving the packet, and it has to be able to point to other destinations like network 1. If something's going back this way, you have to have a route that points to the other destinations, in this case, network 0. Here's what we're going to do right now. I have a video that I want you to watch for Monday. It's going to talk about what you do to set up a route on two different routers, okay? So what we're going to do is kind of walk through for your solution. What you're going to do is you're going to have a similar setup, but instead of having one router, you're going to have two routers. And I want you to walk through the video, and I want you to follow the steps on the video. I want you to practice building a local network with two routers and a set of rules for routing or routes. So when you have a set of rules for how to route, those are called routes. One other thing I want to stress too is for routers that are out on the internet, there's an automatic way to do the routing. So you're going to learn both. You're going to learn the manual routing by setting up two routes between two devices on two different networks. And it's going to work similar to what we just walked through here. But then we're also going to cover the idea that out on the open internet, sometimes sometimes network trunks can die. The power can go out, somebody can cut a cable. And so the beautiful thing about IP networking is all the packets find a different route. They find a different way to flow to get to their destination. So they don't necessarily go the direct route through the next router. They can go out here to a different router and then out there to the next router and then down, and then they finally get to their destination. So routers can create new routes between routers in case part of the network is blown up. If you remember, the internet started when the Defense Advanced Research Projects Agency, DARPA, right? Advanced Research Projects Agency, ARPA or DARPA, said, hey, what happens if our adversaries blow up Chicago? Well, then the western half of the country can't talk to the eastern half of the country. So what do? And that's where the idea for packet-based or packet switch networks came about compared to circuit switch networks. All right. Now I'm using those terms again for module 1, and I hope you haven't forgotten just because you did a midterm, right? Everybody remembers packet switched versus circuit switched? Kind of, sort of. All right. Does anyone have any questions? All right, so this is your study guide. You want to start getting into your study guide in Blackboard and start reading your study guide. That'll help. I will email you the link for the solution so you can start watching it, and you can start working with this to try to start putting things together. That's what I'd like you to do over the weekend. Any questions before we close today?
Yeah. So will we have a solution assignment over the one weekend?
You don't have the whole solution assigned over the weekend.
Okay.
What you have is a video to watch about the solution.
Oh, okay.
And then on Monday, we assign the solution.
Okay.
So all you got to do is watch it. And I would say while you're watching it, try it. Take it as far as you can. Some of you might.
That's cool. That's
Yeah.
cool. Yeah.
Yeah. Because you might like it and it might make sense. And you're like, hey, this is easy. Now that I get the idea that I got to have a route on this side for what's on that side. And then on this side, I have to have a route for what's over on the other side, back over again on the other side again. If I don't have routes going both ways, I don't have two-way communication, right? And that's important. Okay, so enough of that for now. Have a great weekend. We'll see you Monday. Watch for that link.
See ya.
Bye-bye.
Bye,
folks.
everyone.
Bye bye. See ya.